Right, let's go to question 3 of the mathematics paper 2 of November 22 of grade 12s. It reads as follows. It says in the diagram, A with coordinates 4 and 2, B with coordinates 6, -4, and C with coordinates -2 and -3 are vertices of triangle ABC. T is the midpoint of CB. The equation of line AC is 5x minus 6y equals 8. The angle of inclination of AB is alpha. Triangle DCT is drawn such that CD is parallel to BA. All right. The line AC and DT intersect at S, the y-intercept of AC. P, F, and R are the x-intercept of DC, AC, and AB respectively. Okay, that's actually a very awesome love letter. All the information mentioned there does appear in the drawing. We can all see that awesome diagram there with the given coordinates, the points that the lines are cutting, the x-axis and the y-axis as well, and the fact that point T happens to be the midpoint at the bottom of the line CB. Okay, now calculate in 3.1 the gradient of AB. We're looking for the gradient of AB. Gradient is a very simple thing to ask you to work out. It's just changing y over changing x. So the y value at B minus the y value at A divided by the x value at B minus the x value at A. So I'm just going to say the gradient of AB is changing y over changing x. Y2 minus y1 over x2 minus x1. So I think if we look closely there, we're going to have -4 minus 2 divided by 6 minus 4, and I think if you work that out on top, we're literally looking at -6 divided by +2, and that gives us a gradient value of -3. That's the gradient. Okay. Follow-up question says to us here we need to work out the size of alpha. What is the size of alpha? What is alpha? Alpha is this angle here. It's the angle of inclination of the line AB. To work out the inclination, you just need to know the gradient of that particular line, and that's a straightforward question. So the tangent of alpha is given by the gradient of the line that makes the angle alpha, which happens to be the line AB. So I'm quickly going to say that's -3. So that means alpha is going to be arctan, all right, arctan -3. But because it's going to come out negative, it implies that you'll be finding, I think if the line looks like that, the negative gradient I'm going to get is going to be the one that is here, the clockwise version of that angle. We don't want that. We want the one that is on the other side. So if alpha is sitting here, the relationship between arctan -3 and alpha is that they add up to 180. So that's why it's important to always say plus 180 degrees here to get what that angle is going to be. Okay, it's not going to be an acute, it's going to be an obtuse angle. Okay, very, very important for you to figure that out. And then I think if you just press this in your calculator, you're going to get the answer 108.43 degrees to 2 decimal places. Always make sure that your calculator is on degrees when you're computing these things, particularly in trigonometry as well, because if your calculator is set up to something different, you are not going to get the same answers as the ones we are expecting. Right, next question. We need to work out the coordinates of T. What is T? Always ask yourself a simple question. T happens to be the midpoint of the line CB. So T is going to be computed by adding all the axes in those 2 points, dividing them by 2, and then add the y values of those 2 points and dividing them by 2. Remember, like I said, T is the midpoint of the line CB. If you go back to the drawing and you look at it closely, there's point T right there. It's literally between point C and also point B. So we just see this here, and it was also mentioned in the love letter, so we're looking for the coordinates of the point that happens to be in the middle. So we're going to add all the axes. It's going to be -2 plus 6 divided by 2, and then -3 plus -4 divided by 2, and that will give us what the question solution is going to be. So T will be, the x coordinate is -2 on one point, the other x coordinate is 6 over 2, and then the y coordinates are -3, and the other y coordinate is also negative, so you could have written it as -3 minus 4. It's still the same thing. So T comes out as exactly with an x coordinate of 2, because 6 minus 2 is 4 over 2 gives you 2, and then the other one is going to be a -7/2. You could have written it as 3.5, -3.5, but we prefer if you write them as fractions, because then they become usable later on if you need to use them. All right, Now, the next question here is asking us to work out the coordinates of the point S. So what is happening? I'm always asking a simple question. What is going on at this point they're talking about? So they're talking about point S now. Let's see where point S is. Point S lies here. What do we know about anything that has to do with point S? Well, we know the equation of this line AC. It was given to us in the opening statement. So I'm going to go back up and show you that we were told that the line AC has the equation 5x, okay, it has the equation 5x minus 6y is equal to 8, right? So if you know the equation of a line, you can be able to use it to try and figure out what is going on here. So 5x minus 6y equals to 8 is the equation of that line. And what else do we know? We know that point C is on the y-axis because it is the y-intercept of that line and this line as well. So if I know that it lies on the y-axis, we know for a fact that the x-coordinate is definitely going to be 0. So I'm just going to take that 0 and then substitute it in the equation that was given, and that should help me figure out what the y value is going to be. So it helps to know that where lines or graphs cut the y-axis, x is going to be 0. So I'm going to plug that there, and then I'm going to solve for whatever the corresponding value of y is going to be. Okay, so let's do that quickly. I'm going to say we know that it's 5x and x is 0. Okay, we are adding this with the difference of 6y, and then the answer should give you an answer of 0. So I'm sitting here with negative 6y is 8. If you divide both sides by 2, not 2 but 6, you get the answer negative 4 over 3. Okay, that's what you're getting. But they didn't ask you for the y value, they're asking for the coordinates. Therefore, point S will have an x coordinate of 0 and the y coordinate of negative 4 all over 3. Okay. Now I'm going to go to question 3.2 quickly. 3.2 says to us we need to determine the equation of CD in the form y is mx plus c. So what is CD? What's happening with CD? Let's go back and check it quickly. So CD happens to be this line over here, the one that is on the far left, okay? That's the line we're actually looking at. What do we know? We know that it is parallel to the line we've been talking about since we started. And what do we know about parallel lines? Well, parallel lines have equal gradients. So since I know the gradient of the first line AB, it means I automatically know what the gradient of the line DC is going to be. And remember, we worked out that the gradient of this one came out as negative 3. That implies that the other line will also have a gradient of negative 3. Okay, cool. So quickly, the gradient of CD will be the same as the gradient of AB, and it's going to be negative 3 because the line CD happens to be parallel to the line AB. So reasoning is very important. Now, the formula we use for finding equations of straight lines is y is mx plus c. So I need a point on this graph and the gradient. I've got the gradient, it's negative 3. So I need a point to substitute for x and y. And the point I'm picking has to be a point that the line passes through. Now we've got the coordinates of C. We were told what point C is. Its y coordinate is negative 3 and its x coordinate is negative 2. Then from here, we can be able to solve for the value of C. So I'm getting that this is going to come out as negative 3 equals to 6 plus C, and the C value is going to literally be 9. Okay, it's going to be negative 9 is C. Okay, we're happy with that. Therefore, the equation of the line is going to be y equals to negative 3x minus 9. Right. Now, let's keep going. Let's keep going. Go to 3.3. They're asking us here to calculate the size of angle DCA. Angle DCA. All right, let's go back and check it. Angle DCA, angle DCA. Where is this angle? Allow me to clean this up. Let's see what the angle they're talking about is here. We'll get back to maybe removing all the other things. So the angle that's talking about happens to be from point D to point C and then to point A. They're referring to this angle here. This is the angle that we're trying to figure out, okay? We want to find that angle, right? Now, for us to find this angle, we can actually take advantage of what we have done so far. What we've done so far, we've worked out the value of the angle that is here, where alpha is located, okay? I'm just going to put that in, and then we're going to use that to try and figure out how our angle is going to come out as. Okay, this one here, we know for a fact that it is 108 degrees. 0.43, so 108.43. When you're doing geometry questions, always think about what you've done up to the point where you're currently finding yourself, okay? Because it's important. You might find that what you have calculated is useful for you to work out whatever that you need to worry about. So I've got the value of the angle, which is 108.43 degrees. I know that the lines are parallel. And what do we know about parallel lines? Well, when we have parallel lines, you can have that corresponding coincident and alternate relationships popping up. So I'm going to use that relationship. So basically, I'll work out what the value of the angle here is. When I know what that angle is, it's going to be definitely equal to this because they happen to be alternate angles. So now my problems are no longer about finding this angle, they're now about finding angle A at the top there. If I know that, I will automatically know what this one is going to be. Right, now I've got 108.43. So for me to be able to figure out what angle A is, I just have to figure out what this angle here is going to be. So what I'm going to do here is, first of all, work out the inclination here. We can call that theta. Okay, I'll call that theta. Theta, together with alpha, will help me to figure out A, and A will lead me to finding the angle DCA that I'm interested in. Now, I can't find the inclination of the line AC unless I've got the gradient of the line AC. But we've got the equation here. So if I engineer this and try and find what the equation is in standard form, I think it's going to say minus 6y equals to minus 5x plus 8. Okay, if I subtract 5x on both sides of the equation and divide by negative 6, I'm getting that y comes out as I think negative 5 over negative 6 is going to give you 5 over 6x. And then the last value there, 8 over 6 gives you negative, I think it's negative 4 over 3. Okay, negative 4 over 3. Is it 4 over 3? Yes, it happens to be 4 over 3. And we're happy with that because that's actually the coordinates of S. We know we found the coordinates here as negative 4 over 3 for S. So it makes sense that the y-intercept of the line AC would be negative 4 over 3. Now, why am I doing this? I'm interested in the gradient 5 over 6. I'll use it to find the angle of inclination. And that angle of inclination will give me the value of angle A. So remember that. Just please remember that. Okay, so quickly, let's see what we have now. We are trying to find that angle over there. So what I'm going to do now is I'm going to say the equation we have there, the other line, that equation that we have of the other line happens to be, I think it's 5 over 6 axis, okay, minus 4 over 3. This is what the equation looks like. Now we are interested in finding the inclination of that line. So tangent of theta is going to be the gradient of that line with a gradient of 5 over 6. We found that. That means our angle theta is going to be arctan 5 over 6, and arctan 5 over 6 gives you an angle of 39.81 degrees. Okay, pressing your calculator, make sure it is on degrees. So what am I sitting with now? I'm sitting with something that looks like this. Okay, sitting with something that looks like this, and then here one of the angles is 108 point, I think we found it as 108.43 degrees. Okay, we just found the one inside here. It comes out as 39.81 degrees. We are looking for the one at the top, which happens to be angle A. And by using your geometry, you'll agree with me that angle A added with theta should give us the alpha angle that is outside. Okay, that makes angle A to be equal to 108.43 degrees minus 39.81 degrees. Okay, so I think from there the difference comes out as exactly 68.62 degrees, if I'm not mistaken. Now you need to provide the reason why you would make this claim that alpha and theta have to be subtracted for you to find angle A. This is because exterior angle of triangle equals to the sum, I'm using geometry, of the interior opposite angles. Okay, very important. So that's why we're using that relationship to find the value of angle A. Now, once I have angle A, which is 68.62, I can literally transfer that to work out what the value of DCA is going to be. So I'm going to say, therefore, DCA, all right, which is the one that we have here, because there's C here, there's D here, this angle of interest here. Since the lines are parallel to each other, we've got a pair of alternate angles. So DCA is going to be equal to 68.62 degrees because CD is parallel to AB. So we've got a pair of alternate angles existing right there. Okay, cool. So now, next question. Okay, we had enough space there to work that out. So now we want to work out the area of POSC. POSC. Let's go back up and check what is this POSC that you're talking about. So I'm going to go back to the drawing and look for POSC that we need to work out the area of POSC. So let's highlight that in blue. So there's point P, and there's point O, and there's point S, and there's point C. So we've got this here. Okay, we're trying to figure out how big is that space. What is the total area that you're looking at there? Now, there's many ways of actually manipulating your way around here. What I'm going to do here is I'm going to try and figure out the area of PFC instead. Okay, I'm going to work out the area of this shape here, this one, the bigger one, right? I'm going to work out the yellow triangle. Okay, I'll work out the yellow triangle, and then after that, I'm going to work out the green one, which is this one here. I'm going to work out this little one here. Okay, and then obviously the bigger triangle minus the yellow, this green one, which means the yellow triangle minus the green triangle here will give me this entire shape that I'm looking for. See, very clever. I've got the whole thing here. If I subtract this little one here, I'll just be left with this particular quad that they want me to figure out the area of. There's many ways of doing it, of course, but I feel like this is a bit more interesting. So I'm going to say the area that they're looking for. So I'm going to say area. Okay, let's just quickly fix that up for you guys to see. Area of POSC. It's the area of the bigger triangle, PFC, minus the area of the smaller triangle, SOF. Okay, that actually sounds like a good plan. Sounds like a good plan. Right, cool. So let's try and highlight that quickly. Okay, this is what we have. Maybe let's use the same color as the diagram that we have at the top, so we can make use of our colors much more better. So we've got this story going on, guys. There's point P that lies somewhere here, and then there's point C that lies somewhere here, and then there's point O that lies somewhere here, and then this thing actually goes somewhere there to point F. Okay, don't know if it goes to, I think it goes to S. It does. It goes to C, and then it's passing through point S here. Okay, which is where the y-axis is located. So that's O. This is S. We want to find the area of the region. But I'm going to work out the area of the bigger triangle. We'll call it the area of the yellow triangle. Okay, the area of the yellow triangle. The area of the yellow triangle requires me to have the height of the triangle, which is the distance you're moving from point C, going straight perpendicular to the x-axis. Now, since we know the coordinates of C were given to us as -2 and -3, okay, it means we can clearly claim that if that's -2 and -3, the height of this yellow triangle will definitely be 3 units. That's the height. Because the x coordinate is -2 and the y coordinate is -3. Tells you you've moved 3 units going down. That's the height of that particular triangle. Now I'm interested in the base of the triangle because I think we all know that the area of a triangle is half base times height. Okay, so let's quickly set up that equation. So I'm going to say area that we're looking for is going to be equal to, okay, it is equal to the area of the yellow triangle. So area of the bigger triangle, let's see what it is. It's actually triangle PFC. Okay, we want to subtract something. What are we subtracting? We are minusing the green triangle. We're going to minus area of triangle OFS. Okay, which is this one here, this little one here. If you subtract that, we'll be left with what we are interested in. Now, the yellow triangle, the formula for calculating area is half the base multiplied by height. The same thing is going to apply for the green triangle. It's a triangle, the formula of which is also half base multiplied by perpendicular height. So if you just focus on the yellow triangle, let's focus on the yellow triangle and ask ourselves, what do we know? Well, we know the height is 3, okay? So I can sub 3 here. Half base times height, the height is 3. But now I don't know how long is the base from point P all the way to point F. So I can be able to work out the length of PF by trying to figure out what are the coordinates of point F and what are the coordinates of point P. So I know for a fact that point F has a y coordinate of 0. I'm interested in its x coordinate. And I think if we use the equation that passes at point F, which happens to be the equation of the line AC, remember the line that passes here, that particular line, okay, was given to us with the equation, I think it was 5x, okay, minus 6y equals to 8. This is the equation that we were given, which is the equation of C8. It was going all the way to up to point A. We know that it's passing through F as well, right? So I'm looking for the x coordinate of that. That means that's when y is 0. So 5x minus 6 times 0 equals to 8. And then it actually comes out as 5x equals to 8. And our x comes out as 8 over 5. Okay, that's 8 over 5. That's my x coordinate here. 8 over 5 will be the x coordinate. I want to do the same thing for the line PC. Do we know the equation of the line PC? We found it in the previous calculation. We found that the equation of the line PC, all right, let's go back and quickly look at it. I think it was minus 3x minus y. Yes, minus 3x minus 9. The line CD. The line CD passes through point P. That's the line we're looking at. It says y is equal to negative 3x minus 9. It's the line that is going all the way up to point, what point is it? It's point CD, point D. Okay, so minus 3x minus 9 is what we're going to use there quickly. So this was y equals to minus 3x minus 9. I'm looking for the x coordinate when y is 0, because at point P, y is going to be 0. So I'll have 0 minus 3x minus 9, and I think my x value is going to come out as exactly negative 3, because you're going to add 3x on both sides, and then you're going to divide by 3. It's going to give you an answer of negative 3. So the coordinates of P will be negative 3 and 0. And that tells you how long is the line from point P to point F. The entire length there will be 8 over 5 minus negative 3, and then you can get how long that particular base is going to be. Okay, just finding the difference between those two values will tell you how long is the distance from point P all the way up to point F. And I tell you now, it's actually going to be 4.6 units. Okay, 4.6 units when you round off to 1 decimal place. Okay, so that means I've got half base times height. My base is now 4.6. I'll be able to compute that particular area, which is the yellow area. Now I'm interested in the green area. Well, the green area is not a problem. We know the coordinates of S from our previous calculations. It's 0, and the y coordinate is negative 4 over 3. Okay, that literally tells you how much height does it have, because that's going to be obviously perpendicular to the x-axis as well. So the length there is going to be 4 over 3. Remember, distance is not negative, so the height of the green triangle is going to be 4 over 3. The base of the green triangle is from the origin all the way to point F, and we found that as 8 over 3. So that's also, 8 over 5. 8 over 5, not a train smash. That's basically straightforward as well. So the base is 8 over 5. And my height there is happening to be 4 over 3. And then I'll be able to work out the area of the green triangle. Of course, from that, we can then be able to tell you what the final answer is going to be here. When you take the difference between those two things, it comes out as exactly 5,83 units squared, or square units. Okay, very, very simple and straight to the point. As long as you understand how to work this thing out, you will never have issues. It's always how you will work out areas, by just splitting whatever the shape they give you into pieces that you can be able to handle. You could have created squares and triangles if you wanted. You'll still be able to get the same answer. Or you could have used the area rule from the area of a triangle is half AB sine C, and using the angle that is included that we know, you'll still be able to get the correct answer.